Okay, if you missed any part of class today, you were not able to watch what happens on slide 9 in the Desmos activity in terms of being able to convert your equation into graphing form, which is also called vertex form. And there are some steps to it. The first step, number 1, is make sure your equation is actually in standard form. And that's what we've been working on the last couple classes, where we need a 0 over here, and we need the 3 terms. It's a quadratic, so it's going to have an x squared, and then it's going to have an x term, and then a term without an x. The nice thing about quadratics is it'll always have an x squared term. It might not have one or both of these. Those can be missing, but it has to have an x squared term. And then it could have both or one of these and not the other, or neither of these. And those are all quadratics. But standard form is whatever is on the left, you have a 0 on the right. And then once you're in standard form, your second step is to factor and then set those equal to 0. So we worked on this as well. Factoring this means putting the little parenthesis pair, because there's 2 of them, figuring out what multiplies to 16 that adds to 10. Because it's x squared, the first 2 terms have to be x and x, because this is that FOIL process backwards. And we practiced some factoring as well. The factors of 16 are 1 and 16. They don't give me 10. 2 and 8, they actually do give me 10. So I can put a 2 and an 8 in here because they multiply to 16, but that add a negative 10. So a minus 2 and a minus 8. Those do add to negative 10, and they actually also multiply to a positive 16. So that is the second step. The third step is to solve each, and that will give us our x-intercepts. So that means I'm going to solve x minus 2 equals 0, and I'm going to solve x minus 8 equals 0. So I add 2 and I get x equals 2, and I add 8 and I get x equals 8. So my x-intercepts are 2, 0, and 8, 0. And so when I start to graph this, I'll have 2 points on the x-axis to already graph. That's a good thing. So those are my x-intercepts. Step 4, now we're going to go from standard form. We're going to start finding the vertex form. And the vertex, again, if I just kind of graph this real quick, the vertex is that turning point. So it could be at the top, or a parabola could open in our usual U shape, and then it's at the bottom. So step 4 is kind of new. Step 4 is we want to average our x-intercepts. And an average is, in this case, I have 2 of them. So I'm going to average them. So I'm going to write the steps here so we don't lose track of them. So if I average my x-intercepts, and I'm going to switch colors now, I'm going to take my x-intercepts of 2 and 8, I add them up, 2 plus 8, I have 2 of them, I divide by 2, it's a regular averaging. That's 10 over 2, that equals 5. That is the average of my x-intercepts, and that is equal to what we are calling h, which is our horizontal move in our equation. So that's a big deal. H is equal to 5. Step number 5 is plug my h number into my equation. So you have 2 options. You can plug it in up here, or you can plug it in right here. It doesn't matter where you plug it. So I'm going to do both just to kind of show you. I'm going to plug it in up here. So if I put it up here, I'm going to have to calculate what 5 squared minus 10 times 5 plus 16 equals. And that's going to give me 25 minus 50 plus 16. And that will give me, I believe, that's negative 25, so 4, 9, so that should give me negative 9. If I plug it into this equation, which you might like better, I have 5 minus 2 times 5 minus 8. Might be easier. 5 minus 2 is negative 3. Is positive 3. 5 minus 8 is negative 3, and those multiply to negative 9. So it doesn't matter if you put it in here for x, or if you put it in here for x. Either one of them, you put h into either of those versions, and you get your answer. And that actually is our k value. So we plug h into the equation to get k. So we just found that k is equal to -9. So up here we have h is equal to -5. Sorry about that. I'll rewrite that so it looks nice and neat. Let's try to be consistent here. -5. Sorry, it was equal to +5 because 10 divided by 2 is 5. That was our h. That's our k. We're making steady progress here. I can now move to step number 6, and apparently I'm still in green. And now I can write down the vertex. And that's supposed to be over here. I'm going to write down the vertex. The vertex is just my h and my k. So I just have to write down the coordinate hk. That is my vertex. And we know that it's 5, -9. Boom, there it is, h and k. That's it. And then the last step, step number 7, is put in vertex or graphing form. I call it vertex form. I think the Desmos activity called it graphing form. They're the same thing. And so I'm going to write that down for you. Generically, graphing form is y equals, and I'm going to put this right here, ax minus h squared. That's why I know it's a quadratic, plus k. And now I can just plug in. Now, we didn't worry about this a value. There was no a value. We'll deal with that later. Or actually there is, it's just 1. So I don't need to write anything there, it's just 1. But what I have is an h value of 5. So if I put a 5 right here, I'm just going to do it right over top for now. And my k is -9, so in place of k I put in -9. My equation is y equals x minus 5 squared, and this is plus a -9, which is the same as -9, and that is vertex or graphing form. And the reason it's called graphing form is I know to move that vertex, this guy right here, this is exactly what we talked about last unit. This means I move this vertex 5 units to the right, because it's opposite, and 9 units down, and bam, I have my graph. There you go. That is what we talked about on slide number 9, and now you're going to put that to good use.